Okay, everybody, so this Mr. Bell's, again, this is section 10-3, and it's on what we call two-way tables. So one of the first problems that's going to show up, and just kind of a way to do probability organized in the chart, is a table that looks like this. In fact, this is going to be your number 3. And it'll give you some information. Basically, we want to make sure that we understand that as we go across the table this way, these two boxes will add up to whatever's in this box. And we go down the table this way, these two boxes will add up to whatever's in this box. And of course, I can't tell you what these two are right now because there's 3 things and I don't know 2 of them. I can't do this one, I can't do this one, I can't do this one. But if you look right here at the end, this box right here plus 10 has to equal 50. So that would have to be a 40. And now if this box is equal to this and this is 6, then this would have to be a 34. And if this is 34 and this is 38, then you know that this box would have to be a, oh, you got it, a 4. And then 4 and this box right here has to equal a 10, so that's got to be a 6. And then 6 and 6 is 12, or 38 and, yep, you got it, 12 is 50. So just know that when you're taking a look at one of these things, it might have been a situation where they gave you some information. They said, of the 40 people who passed, 34 of them studied, 6 of them didn't study. Of the 10 people who failed, 4 of them studied, 6 of them didn't study. Of the 38 people that studied, 34 of them passed, 4 of them didn't. Of the 12 people that didn't study, 6 and 6 of them did. 50 total people took it. So just a kind of a way to organize this chart. So if we were to say, hey, what percentage of people who failed studied? Percentage of people who failed uh, and actually studied would be this. So the total people that were failed is 10. That's our total. The ones who studied is 4. So that would equal 0.4 or 40%. So that's what one of those things would look like. Okay. So the first 2 problems are the same things. They're just putting in information in the chart. The third one, they give you some outside information. And I just made this one up, but it's kind of what they're looking for. So there are 160 total males and 200 total females. So if I was to look at this chart and I go across, well, males total goes right here. So that's got to be 160. Females total has to go right here. That's got to be 200, which means, of course, we know that this box right down here would be a 360. That's a way that I could do that. Now, this says listen to internet radio. So a yes, they listen to internet radio, or a no, they don't listen to internet radio. So on this one, 87 males do listen to internet radio. So that would be an 87 there. Females would be 113. So that would go there. And now I should be able to fill in these other 4 boxes based on this information. So if this is 87 and the total is 160, then this must be 73. If this is 113 and this is 200, then this must be 87. If this is 73 and this is 87, this should be 160. And if this is 87 and this is 113, this should be 200. And you can see that the totals work out that way. 200 and 160 is 360, the same way that it was before. Now, just because we have numbers like this, 87, 87, 160, 160, 200, 200, they don't have to be like that, but the totals do have to work out. So these are called marginal or numbers that are in the margin. So relative marginal frequency, 160, 200, 200 to 160 here. So how does that play a role? So they're going to ask you some things. So they're going to ask you 2 things here. One, what are the marginal frequencies? Well, those are the actual numbers that go in those boxes on the outside. So from that last chart, they're going to ask you in total, how many people were surveyed, males, females, of the people surveyed. People said yes, people said no. Those are just the numbers that are going to come in those margins. Okay. The next part of this chapter, this unit, this section of stuff deals with conditional relative frequencies. So in other words, what are some of the percentages that you would get in this thing? So this one, problem number 11, says the survey finds that 110 people ate breakfast and 30 people skipped breakfast. Of those who ate breakfast, 10 people felt tired. Of those who skipped breakfast, 10 people felt tired. Which of the following represents a two-way table that shows the conditional relative frequencies based on the breakfast totals? Well, it's easy to be able to eliminate one of these ones. This one does not have conditional relative frequencies. Again, conditional relative frequencies are percentages based on the numbers that are above, and the column should add up to 1. So if you look right here, 0.83 and 0.5, that can't add up to 100%, so that is going to be wrong. You look over here, all you've got is two things, and neither one of them add up, so that's got to go away. Whereas over here, it's a little bit easier to be able to tell that this one's going to work. So now the question is, where do these numbers come from? Where does 0.091 come from? Well, it says breakfast, ate. Yes, they ate breakfast and were tired. So we come over here and we go 110 people ate breakfast. 10 of them were tired. So if I do 10 divided by 110, that's 0.091. That's where that comes from. Where this 0.333, hopefully this makes sense to you, this says did not eat breakfast. Well, that's 30 people skipped breakfast, so that's the total from this column. And 10 of those people felt tired, so 10 out of 30 is 1/3, or right there. Is that good? And I'm hoping this makes sense. If 10 people felt tired, then 100 people didn't feel tired. So 100 out of 110 is this one right here. And 20 out of 30 is this one right here. And that's where we can get those conditional relative frequencies. Okay? So where does it go from there? It goes to a problem like this, where they're looking at a chart that has conditional relative frequencies already in it. What we're wondering is, what do some of these things mean? So it says 3 different local hospitals in New York surveyed their patients. The survey asked whether the patient's physician communicated efficiently. The results given as joint relative frequencies are shown in the two-way tables. So two-way tables, yes or no, are 3 different categories: Glen Falls, Saratoga, and Albany. Okay? So what's the probability that a randomly selected patient located in Saratoga, so it just says this, and I'm going to highlight that, so located in Saratoga, was satisfied with the communication with the physician. So if it says that they're located in Saratoga, we need to look at these two totals. And then we want to know, were they satisfied? So satisfied, yes, is 0.288 out of the sum of the people in Saratoga. So 0.288 plus 0.077. And it's that math right there that we would do to be able to get that answer. Okay? So this next one says, what's the probability of a randomly selected patient who is not satisfied with the physician's communication? So they're not satisfied. That's these ones. Is located in Glen Falls. Okay? So that's 0.042 out of the sum of those 3 things that I just put up there. Good deal? And I'll let you go ahead and explain or figure out this last one here, because again, I don't want to do all of them for you. But hopefully that helped in terms of working through these problems. So this next one, it's a pretty big one. It talks about which one of these things is an error. So the probability of yes, given the fact that it's in Tokyo, yes, given the fact that it's in Tokyo, is shown by probability of Tokyo and yes divided by the probability of Tokyo. And then they got some numbers there, and they're saying this is wrong. What is wrong with this? So the first thing says the values in the formulas are correct, but there's a decimal place error in the division. So that would mean if 0.049 divided by 0.356 isn't 0.138, that might be where the division was, the decimal place error. Okay. This one says the formula is correct. So do you agree that that's correct? Yes or no? And then they're saying that probability of Tokyo, P of Tokyo, is not correct, and that should be 0.39. Okay, so if you look up here at the chart and you go, the probability of it being in Tokyo, this one right here, should be 0.39 and they use 0.356, then you pick that one. Heck, yes, that's a winner, that's a check. But that's kind of how these things are written. So then says correctly find the probability of yes in Tokyo and round your answer to 3 decimal places. Well, now that you know what the formula should be, you should be able to go ahead and do that. And then put that number right in that little box for the things. Okay. So the last one that we have here is another one. It's saying that there's an issue with the probability for these two-way tables. Okay. So I'm assuming you can do this completely on your own now. It shouldn't be too much of a problem. What I really want you to get out of this are two things for this section of materials. One, these are called two-way tables, and they can have just totals, the numbers that are in there, and then their totals on the end. So 34 and 6 is 40. So the actual numbers themselves. And these things right here, these things are called marginal frequencies because they're the ones out in the margins. And then we can take these numbers and actually do some of the division in them and put in these things. And these are called relative frequencies or joint relative frequencies. And that's actually the probability of each of these things occurring, not the actual number divided by the total from the amount. Okay, so that's the different. Marginal frequencies are whole numbers like that. Relative frequencies are relative to the totals that are in there. Okay, so hopefully this was beneficial. This is a pretty short little unit on this stuff on 10.3, but hopefully this is helpful to you. So again, check mark. Please stay on top of this stuff. You're doing a great job. Let me know if you like the videos or not. Send me an email. For some of you, any communication would be great right now. That's awesome.